Hello, and welcome to another video for building complex cohort designs in Atlas. Today we're going to be going through an example of a cohort definition that is defined in Phi KB. It's going to be a cohort definition for type 2 diabetes. And we will be going through a walkthrough of Atlas and describing the concepts that we learned about from the other videos about queries, counts, groups, and other functions of the Atlas tool. So this flowchart describes a decision tree that defines an algorithm to identify type 2 diabetes cases. We'll follow a procedure to convert this flowchart into the Atlas cohort expression. For reference, we have the URL to the actual definition here, if you want to review that on your own time. So these indicated paths show all the possible routes from the starting node of no type 1 diagnosis through case identification. There are 5 paths in total, which we can create the Boolean expression to represent each path. Each of these paths are represented by a different color, and you can see that by following each unique path will lead us to a case. In order to define the logical AND statements to represent each path, we need to identify each query and count operation involved for each path. So I have color-coded each of the boxes that represents the clinical concept that's involved. We have the type 2 diagnosis, where we want to do at least 1, exactly 0, or at least 2. In these cases, we have a type 1 diabetes treatment, where we're asking for either at least 1 or exactly 0. We have a type 2 diabetes treatment, where we're asking for at least 1 and exactly 0. And we're asking for an abnormal lab, where we're looking for at least 1. The other interesting case of this flowchart is that there is actually a case where we're looking for 2 records in observational data, where the type 2 diabetes exposure or the drug treatment is before the type 1 diabetes treatment. And that is in this case right here. Each of these paths are groups. And in order to find all the cases, we're going to use a group of ORs for each path, and each path is going to consist of a series of ANDs. So these are those paths. The red path is saying exactly 0 type 2 diabetes diagnosis and at least 1 type 2 drug and at least 1 abnormal lab. So that's following this path here. The yellow line follows a at least 1 type 2 diagnosis and then no type 1 treatment, and then no type 2 drug, and then you have to, in that point, have a lab, an abnormal lab. The green line follows the path at least 1 type 2 diagnosis, exactly 0 type 1 treatments, and at least 1 type 2 treatment. That will lead us to a case. The purple is at least 1 type 2 diagnosis, at least 1 type 1 treatment, at least 1 type 2 treatment, and then the type 2 treatment precedes the type 1 treatment. And that will be a case. And then finally, our last path is at least 1 type 2 diagnosis, at least 1 type 1 treatment, no type 2 treatment, and then 2 diagnoses, at least 2 diagnosis codes of type 2 diabetes. And that will be a case. Note that all the paths require exactly 0 type 1 diagnosis, so we will exclude those from the entry events, all of our entry events at once. We're not going to represent those in each of the paths. We can just take care of that up front. So in the Atlas walkthrough, we'll show creating and import concept sets for each of those clinical concepts. We'll specify the entry events of type 2 diagnosis, type 2 treatments, or abnormal labs. We'll define 1 inclusion criteria to identify a type 2 diabetes case. We'll limit to the earliest event after inclusion criteria. Atlas will consider all time prior to cohort entry when considering if other conditions are met. And the cohort exit will be the end of observation since we consider type 2 diabetes permanent. The other last note on this is that VKB looks for cases, as in this person is a case, true or false, or is a case of type 2, whereas Atlas would want to define the eras of time. So Atlas will account for time, where I believe the VKB algorithm actually just looks across all time in the patient record. Instead, for us, we will be looking at each of those moments of entry and determining if that person should be included into the cohort. So we'll switch over to Atlas. And this is going to be done on the demo site, atlas-demo.odyssey.org. From the homepage, we'll just go ahead and define a new cohort. And we'll follow the recipe that we followed on the prior slides about what steps are we going to do. So we said that our cohort entry events are going to be either a diagnosis of type 2, so a condition occurrence, and we'll import a concept set, and we'll search for type 2. In fact, we'll start with type 2 treatments for now. T2DM. Medications. Okay. So I'm actually going to, I said condition at first, but I'm going to start with treatments first because I would like to show what how to construct a new cohort from scratch, concept set from scratch. And I think that would be easier to do with a type 2 diagnosis code instead of the list of all the medications involved with type 2 diabetes medications. So I'm going to restart this a little bit. I'm going to delete this, go back and talk about the drug exposure. And since I've imported the medications, I'm going to select that. The next I'm going to do is I'm going to add a condition occurrence. I'm going to import a concept set. And in this case, I'm just going to say new concept set. I'm going to rename this concept set to type 2 diabetes mellitus, and we'll just leave it at that, or you can say it's a diagnosis. And we will go over to our vocabulary, and we're going to search for, and we can see at the top here that our active concept set that we're going to be editing is the type 2 diabetes diagnosis concept set. So I'm going to search for diabetes, and what should come back is a list of everything with diabetes in it, and I will limit myself to searching for type 2 from SNOMED. So it comes at the top of this list here because it's sort of this way, but I can sort by SNOMED or filter by SNOMED and standard concepts using the filters, and it'll help me narrow down the actual concept of interest I'm looking for. But basically, we're going to say that we're going to use type 2 diabetes right here. So to add it to my concept set, I'm going to click on this shopping cart and then click back to my concept set. And we'll see that the type 2 diabetes concept is now in my concept set, but I would like to include all descendants of type 2 diabetes. So I click on this descendants, and it includes now 17 concepts. And as we saw in the other videos, when I described this, we can look at the included source codes and other functions to see what are the source codes that map to this concept set. But for now, we'll just look at it as this is including the type 2 diabetes concept and all descendants. The next thing that we want to consider is we want to say that the person could enter at the time that they get their measurement taken, the HbA1c measurement or an abnormal lab. So this could be a very complicated expression to describe like what is an abnormal lab value, but we are going to instead make it simple where we're going to just import a concept set for HbA1c. We have a code list already defined for this. I think this one will work fine. When I import it, if I actually want to have it a better name for this, I can just click on it and then rename it here. And so this is my HbA1c measurement. And I go back to my definition and it's renamed here. And so now we're saying that a person can enter the cohort at either a moment of a type 2 medication, type 2 diagnosis, or a measurement of a HbA1c measurement. And let's just say that we can define a measurement value, value as number. If that is greater than or equal to 6.5, we'll consider that an abnormal measurement. Okay. And that is our entry events. We want to use all events because we want the opportunity to identify when a person becomes a case using all these events, not just the earliest of those three. We want all the events. So looking at a patient timeline, you will have some medications, some diagnoses, some lab tests, and we want to basically find the moment that a person satisfies one of the 5 paths to get into the phenotype for type 2 diabetes. So going back to our flow chart, we saw that we had these paths and we defined these actual expressions that we we're going to use. And we said that we were going to say that all paths required no type 1 diagnosis. So we're going to go ahead and exclude that from this set of events. And we're going to do this in one shot by restricting the initial events. Clicking on this allows us to add an inclusion criteria that is a group. We're going to check to see that they did not receive a diagnosis of type 1 diabetes. So we're going to add a condition occurrence. We're going to say exactly 0. We are going to import a concept set for type 1 diagnosis right here. And we're saying exactly 0 anytime before, on or before the index. So between all days before and 0 days after. We'll just say it. We'll include the index event to say like they can't have any condition diagnosis of type 1 diabetes. I believe for PKB that they probably don't use the notion of a prior and post index date or anything like that. They're just looking for cases. So it's very likely that they looked through the entire medical record and excluded people with a type 1 diagnosis. But we're going to let that slide for now. We're going to say that we're only going to look at time up to the inclusion event or the index event and look only time up to that point for any type 1 diabetes. And what that kind of will allow us to do is basically say that there are people that were identified as type 2, possibly incorrectly, but identified as type 2, and they were treated that way in our data until the day that they were a type 1 diagnosis. We could interpret the data to behave that way. It would take more analysis to make that assertion. But what we're just going to do, the whole point of this is that we're going to only allow entry events if they did not have type 1 diabetes prior to index. That's what we're doing here. Okay, so now we're going to go on to step 2 of the process, which is define inclusion criteria. We're going to define a inclusion criteria. We're going to name it. This is a type 2 diabetes case. And we said that it can be any of 4 things, 5 things, 5 paths. So a path is going to be represented by a group. So we have this outer group saying it can be one of these things, but then we need to add a group for the ands. So we're saying all of path 1, path 2, path 3, etc. So just to make it clear in the UI that that's what we're going to be having, I'm going to add 4 more groups to this list here. So 1, 2, 3, 4, 5. Okay, that's just to allocate the groups so that we just keep it clear in our own minds what we're doing here. And you can even read it saying having any of the following, this or this or this or this, etc. Okay, so let's go back to the first expression, and we said it was 0 type 2 diabetes diagnosis, at least 1 type 2 drug, and at least 1 abnormal lab. So we'll go ahead and do that. So we have a condition occurrence. So exactly 0 of the type 2 diagnosis. So we have exactly 0 that between all days before and 0 days after. So up to the and including the index date. We're going to add another one for the drug. Or, I'm sorry, and they had a type 2 medication all days before, up to and including the index date. And they had a lab, an abnormal lab. So we said this measurement all days before to 0 days after. And we said that an abnormal has a measurement value of greater than or equal to 6.5. Okay. So these three things, and just to confirm, to go back, those three expressions represent these three exceptions in this first path. Okay, so that's one down. The next group has a condition occurrence. Now in this case, it's at least one condition occurrence of type 2 diabetes. All days before, up to the index. And a drug exposure. In this case, so we're hitting a new clinical concept here. We're supposed to say no type 1 drug. So we don't have a type 1 medication yet. So we're going to look for that for type 1 VM medications. Okay. So we've now imported that into the concept set. It's assigned right here. And we're saying that they have to have exactly 0 type 1 medications between all days before and 0 days after. The next one is going to be no type 2 drugs. So drug exposure, exactly 0 type 2 drugs between all days before and 0 days after. And a lab. Add the criteria to group. Add our measurement. You have to have at least one lab. Measurement. Add attribute. Sorry, measurement as a value, as a number, greater than or equal to 6.5 between all days before and 0 days after. Okay, so our second expression here, I'm going to make this a little bit slower, lower resolution, just to like fit it a little bit more. So our second expression has these 4 expressions. And just flipping back to our notes, these are the 4 expressions: at least one diagnosis, no type 1 drug, no type 2 drug, and with an abnormal lab. So that's this path. Next. So in this case, we're going to have a condition occurrence. So in this case, we're saying at least one condition occurrence of type 2 diabetes, 0 type 1 drugs, and 1 type 2 drugs. So at least one diagnosis of type 2 diabetes between all days before and 0 days after index. Now we're looking for 0 type 1 drugs. Exactly 0 type 1 medications between all days before and 0 days after. And finally, you have to have 1 type 2 treatment. So we will add a drug exposure, at least 1 type 2 medication, all days before, 0 days after index. And this equates to our green path, this one right here. 2 more to go. So in this case, we're going to say at least 1 type 2 diagnosis. Type 2 diagnosis between all days before and 0 days after. And you did receive a type 1 treatment. So a drug exposure of a type 1 treatment. and you had a type 2 treatment. And let me not jump too far ahead too quickly. All days before and 0 days before. Now we're saying a type 2 treatment between all days before and 0 days after. And we want to say that there was the type 2 treatment preceded the type 1. So here we're saying that, so basically we're saying that we want to find a type 1 treatment that had a type 2 before it. So I'm going to add a drug exposure here. I'm going to say I'm looking for a type 1 drug between all days before and 0 days before. And then I have to say, I'm saying there was a prior type 2 treatment. So what we're going to do is we're going to add a group to this query. So I'm going to add this nested criteria. And now we can say we need to find a type 2 medication all days before. And we'll say 1 day before the index date that refers to the type 1 medication. So when we look back in time from our entry event, we want to find a type 1 medication. Now that type 1 medication could be on the index date. That's fine. We find it. And then we also have to have the type 2 medication before the type 1 medication. So that's this expression right here. And in this case, we were saying all days before to 1 days before. And for the actual drug exposure of the type 1 medication, that can be any time before up to and including the index date specified here. Now, if we look at this closely, we can see that we're looking for, like, both events have to exist in history. We have to have the type 1 medication and then the type 2 medication. So that's kind of making these two expressions redundant. Like, this asserts that we found both. If this passes, if this count criteria works, that means we found the type 1 and found a type 2. So we don't have to assert it again here that we have to have a type 1 and we have to have a type 2. So why don't we simplify this a little bit and delete this one and delete this one. And now the expression of finding the diagnosis of type 2 diabetes and if a type 1 with a prior type 2. That is really what this path expresses. Taking a look at that path, that saying that you have to have a type 1 and you have to have a type 2, and then state that it has to proceed. These two facts are restated in this criteria. So we can just say this one, we can just leave it with the type 2 preceding type 1 rule. Okay, and we have one more to go. So we will go, we want to say at least one type 2 diagnosis. At least one type 2 diagnosis between all days before and 0 days after. Then we want to say, and there was a type 1 drug. I'm sorry. Yes, and there was a type 1 drug. All days before to 0 days after. Then we're saying no type 2 drug. So we'll add a drug exposure rule, exactly 0 type 2 drug, all days before to 0 days after. And then in this case, the special case here, if you're at this box, the only way you can make a case at this point is if you have 2 type 2 diagnoses. Now, there's 2 ways of doing this, but we'll do it the simple way. And that is we're going to add a condition. And we'll say that we want to see the type 2 diagnosis, at least 2 type 2 diagnoses between all days before and 0 days after. So the other way of thinking about this is definitely logically what they're saying. They're saying they want to see 2 diagnoses, but that could be 2 diagnoses, but maybe on different days. This will allow the same diagnosis on different record be counted independently. So this would pass if both diagnoses are on the same day. If instead we wanted to say that, no, the diagnosis should actually be on different days, then we could say something like this, where we say at least one diagnosis of type 2 diabetes, and then same thing that we did above with that nested for medications, we can do the same thing with the diagnosis, where we'll add a nested group and we'll look for condition occurrence of the type 2 diagnosis starting between all days before and 1 day before. So now this diagnosis will only pass, this count will only pass if it finds a diagnosis record, and that diagnosis record has another diagnosis record sometime before the diagnosis of this condition occurrence, but it can't include the date of this diagnosis. So it's going to look for all days before to 1 day before this diagnosis date. And that is our last group. Now, we said that that we want to state that once a person enters the cohort, they're going to be permanently in the cohort. So our cohort exit is going to be until end of continuous observation. And because that's the case, we can actually use the earliest event here because we don't need to see that the person constantly asserted that they were in the cohort for entry into the cohort. We can just say that as soon as they're in, the first time that this qualifying inclusion criteria qualifies them for the cohort, they're in forever. So we only need one event to qualify them. We don't need to keep more and more events because they are always going to stay in the cohort. They never leave. And because that is the case, this other thing about cohort errors is pretty irrelevant because this person is only, each person can only have one error because they enter and then stay forever. So there's no point in thinking about how close should episodes be together in order for them to be considered the same error. So that covers our 4 steps. And now we have a completed cohort definition. And I can just name it. There you go. And save it. And we have a new cohort definition. Okay, back to our slides. So in conclusion, some algorithms are described through the use of decision trees, like we saw in the VKB's case. In order to convert the tree into an Atlas cohort definition, we identify the unique paths to the case node and define queries and groups for them. In Atlas, concept sets were copied into the cohort definition for use in the queries. A person can enter this cohort at a time of either a type 2 diagnosis, treatment, or abnormal lab value. A person stays in the cohort until the end of observation, and I stay here, or if a type 1 diagnosis occurs. This is because from the data perspective, the person is seen as a type 2 patient up until the type 1 diagnosis. So actually, let me flip back and actually add that additional logic to our cohort definition. So we have our cohort definition, and we said that once they enter, they're in forever. But VKB made a point of saying that, well, if you have a type 1 diagnosis, then you can't have a type 2 diagnosis. And what we were identifying in our data was that there were moments in time where the person was only known as a type 2 diagnosis, but there could be a time when they will and a diagnosis of type 1 will be issued for this person. So what could we do? We could either rule out those people by looking fore and aft of the index state and clearing out people, and even looking in the future of the index state and saying they could never have type 1 diabetes diagnosis ever. But in this case, we're allowing people that have future type 1 diabetes to get into the cohort because as far as the data is concerned, these people were probably treated as type 2 patients. And what we'll do instead is we'll say that they're in the cohort forever unless they actually have a type 1 diagnosis. So to do that, we will add a censoring event to our cohort definition. So a person will exit the cohort if they have a condition occurrence of a type 1 diagnosis. So now we have a cohort definition that allows people to enter the cohort and stay in the cohort until they are diagnosed with type 1. And even though type 1 and type 2 diagnoses are different things entirely, it's not like type 1 becomes type 2. But like I said, for this particular cohort design, we'd like to capture the people that would be phenotyped as type 2 diabetes for the duration that they would be classified as type 2. From literature, you would find that you can be diagnosed with type 1 later in life, but type 1 is more of a genetic disposition to the insulin production and having antibodies against insulin in your blood. So the point there is that we can create a cohort definition that will at least capture the period of time in the data that you were perceived to be type 2 diabetes, and then stop that perception once a type 1 diabetes event is observed. So, thank you very much for your attention, and I hope this was helpful. If there's any other questions that you wish to have about creating cohort definitions, the Odyssey forums is a great place to reach out and make contact. That's at forums.odyssey.org. Thank you for your time, and have a good evening.